Hello all, and welcome to the video on exercise 5D. We are going to look at factorising trinomials of the form ax squared plus bx plus c. So we're going to be factorising quadratics, but this time the one thing that's different from last section is we're going to have this a coefficient. Okay? Previous section where we looked at factorising via inspection, that was always 1, and you can probably hear my cat meowing at me in the background. Okay, so just as a quick review, in the previous exercise we looked at factorising trinomials of the form x squared plus bx plus c, so that's that where we only have a coefficient of 1 there. So let's do a quick review. So have a go at these, pause the video. Sorry, my cat face. Pause the video, have a go, and then come back and have a look at how I do it. So we've got a 12 multiplied 12 will be 3 and 4. So we've got x plus 3, x plus 4. So 3 times 4 is 12, 3 plus 4 is 7. So that works. 6, 3 and 2, we need negative 5. So that is the hint that we're going to have negative 3. Negative 2, so negative 3 times negative 2 is positive 6, negative 3, take away 2 is negative 5. Okay, 26, so this might be, 13 and 2, and we've got negative 11x, so we'll go x minus 13, x plus 2. So negative 13 times 2 gives us our 26. Negative 13 plus 2 gives us our negative 11, so that works perfect for the inspection method. I'm just going to close the door to keep it out of the room. Okay, my apologies. So next slide, let's get into it. Let's get into the cross method. So what is the cross method? Well, the name is sort of a big giveaway. We use a cross. So I'm going to go through the method first, doing a brief explanation, then we'll actually have a look at the notes and delve deeper into it, and then do another example, and hopefully that'll tie it all together. So we'll draw a cross underneath our function. Okay? And what we're going to do at the ends of each cross, we're going to write the factors of the terms above it. And it's very much like the inspection method. We're going to get some numbers that multiply together and then also end up adding together to make our middle term. It's just a little bit more convoluted or complex because of this 2 here. Okay, so we start with 2x. We start with our first term. So we need to write down 2 factors of our first term. Now, in this case, it's pretty easy. There's only 2 options. We've got 2x and x. Okay. Now, if we had 4x squared there, we could have 2x and 2x, or we could have 4x and a single x. Okay, but that's nice and easy. Now, 15, we've got some options. I'll write them over here. 15, we've got 15 times 1. We've got times 15. We've got negative 1 times negative 15. We've got 3 times 5, and we've got negative 3 times negative 5. So we've got a bunch there, and I'll scribble that. It's just one inverse. And we're going to put them at this side, just like we did before. Now, this is where a bit of trial and error comes in. And what we're aiming for is that we'll multiply along our lines. So we'll multiply up along this line, whatever's this end and this end, we'll multiply together. And then along this line of the cross, we will multiply together, okay, which will be here. That'll give us something there. That'll give us something there. And what we're going to do, those 2 things, those 2 terms that we get in the end, okay, when we multiply along our lines, we will add together. And whatever we get should be 13x. That's what we need. We need to get what's our middle term. So let's have a go. We've got 2x, and we're going to make 13. So this is going to work out. And it comes with experience. You'll get used to looking at the numbers and seeing what they're going to work. But if I put a 5 here and a 3 here. Now I multiply along the line. So 2x times 5, that's going to give me 10x. And then I do x multiplied by the 3 gives me 3x. 3x plus 10x gives me 13x. That works. What this cross now gives me, these numbers at the top, okay, is going to be our first bracket, 2x plus 3. And then these numbers down the bottom are going to give me my second bracket, x plus 5. So the name cross method comes from making this cross where we multiply along it. The terms on the left side of the cross are factors of our first term. The terms on the right side of the cross are factors of our third term. When we multiply along our cross and we add our result, should give us our middle term. So let's have a look at that in more common note. So factorize 2x squared plus 13x plus 15. So we need to find the factors of our first term, and then we're going to find the factors of our third term. Okay, and they're going to be on the right hand side of the cross, and our factors are going to be on the left side. Now, if we put the 5 and 3 the other way around, it won't work. It won't work, and you can try that. We'll get to it. And we looking at the cross on the right, we now need to multiply along the line. So like I drew, and I'm pretty sure I drew that with a red, we multiplied down across there, and then we multiplied across there. So x times 5 gave us our 5x. Oh yeah, 2x. Oh, so this one's done it slightly different. 2x times 3 gives us 6x. Okay. That will equal, add together 5x plus 6x gives us 11x. Now, the middle term, we needed 13x. So this was actually what I was talking about, where the 5 and 3 the other way around, it doesn't work. Okay, because we multiply along across 5x and 6x, we add them together, we got 11x. That's wrong, no good. Okay. So what you would do in this case is you would try different factors here, you would switch the order of them. So that's what happens down here. Adding the above gives us 11x. This number should be the same as the middle term. Should be the same as the middle term. Doesn't work in this question. As this is not the case, either we try different factors or alter their positions. So in this case, we switch the position. We switch the position. Multiply along the cross, 2x times 5. Multiply along the cross gives us 10x. Multiply x by 3 gives us 3x. Add them together gives us 13x. And that means, I'll go back to blue so I match the previous slide, 2x plus 3 is my first bracket. And second bracket is x plus 5. So let's have a go at doing some of these. Okay, factorize 6x squared minus x minus 12. So this one's a little harder, as it says up here. There's only one set of factors for 2x squared we had on that, and there was two set of factors for 15. This one, we've got 6, so let's have a quick little sketch to show you how many combinations you can get pretty quickly. So 6, we can have 3 times 2, negative 3 times negative 2, 6 times 1, negative 6 times negative 1, and then our 12 is even worse because it's a negative number. So to get 12, we can have 3 times negative 4, or negative 3 times positive 4, 6 times negative 2, or negative 6 times 2, or 12 times negative 1, or negative 12 times 1. So there's 4 combinations we could try for the left side of our cross, and there is 1, 2, 3, 4, 5, 6 combinations we can try for the right side of the cross. Now you'll get a little bit of a feel for these to do with scale, okay? Like if we only need a negative 1x in the middle, so it's probably unlikely we're going to be using the 12. If we use a 12 on one side of the cross, we're going to end up with very large numbers very quickly, and it's not going to sort of cancel out really easy. So let's give it a go. We're going to draw our cross, and we're just going to start trying. Okay. So let's try 3 and 2. Okay. And so I'm thinking I need to end up, I'm going to put a number there. When I multiply them, I get two terms, and when I add them together, I need to get -1x. Sorry, just kicking the cat out again. No, out. Okay, I need -1x. So realistically, I need -1x. Realistically, one of these two numbers just needs to be one larger or one smaller than the other. So 3, 2, I'm gonna thinking 3 and 4. That would work. 3 times 3 is going to give me a 9. 2 times 4 is going to give me an 8. So that's going to one larger than the other. Now I just need to get the signs right. So I'm going to put my 4 there and my 3 there. It needs to be negative, so that would need to be the negative because that'll give me -9x. This will give me positive 8x. So positive 8x plus, we're working down this way now. We take our positive 8x, add our other result, and that gives me -1x, or -x, which is what we needed. So that works. So my factorization, and I've left the x's off, but it's clear that at the front there will be x's to give me the x squared. That means my factorization is 3x plus 4, 2x minus 3. And that is our factorization. It'll come with practice getting the numbers. I knew straight away, needing a -x in the middle, I was very unlikely to use the 12, so I just get two bigger numbers, even the 6. So 3 and 4 has worked out quite nice. So let's extend the concept a little bit. Now, if you're still struggling with this part, this is when you go to your textbook and practice a couple of the basic ones. Once you get the pattern down, you'll be able to incorporate it in more complex problems like the one I'm about to show you. So if you hear this is enough and that's your mental load, that's completely fine. Go practice, then come back to the rest of this video. So extending the concept. Okay, we can extend this to simplifying fractions. What does this mean? Well, when you look at this, you're like, oh my God, there's so much here. What am I going to do? But we're in the topic of quadratics. Okay? This first numerator is a quadratic. This first denominator is quadratic. Second numerator, quadratic. Second denominator, quadratic. There's nothing new here. It just looks scary because it's big. Okay? So as soon as you see stuff like this, it's just go, where's the basic things that I'm doing hidden? Well, if we look at let's actually write it out by flipping the fraction first, just so we can cross cancel, because if you don't flip, you can't cross cancel across a division. So let's, -10 times by, and when we take the reciprocal, so we're pretty much just flipping our fraction, 7x minus 5 all over x squared plus 9x plus 14. Okay, so where do we start? Well, let's look at the first numerator and go, what if we look solely at the numerator, looking solely at this first numerator, what is it? Well, it's x squared subtract 4. Something squared minus 4. This 4 we could write as 2 squared. We have something squared, take away something squared. We have the difference of perfect squares. So first off, straight away, if you remember from previous videos, if we had a squared minus b squared, we can factorize that as a minus b, a plus b. So that's what we're going to do. We'll turn our first numerator into x minus 2, x plus 2. There we go. So we've done that. Cool, we factorized the first numerator. Let's look at the first denominator. We're going to look at this bit here. 3x squared minus x minus 10. So straight away you'll see we have a coefficient for the square term. First thing you should be thinking is not cross method. The first thing you should be thinking is, can I take out a common factor? A lot of times if you can take out a common factor, it makes the whole problem a lot easier. In this case though, we can't, so we are going to go to the cross method. So I'll do it over here. We've got 3x squared minus x minus 10. Draw my cross. This is pretty easy, and that's going to be a 3x and a 1x. Now 10 will be either 10 or 10 and 1 or a 2 and a 5. Reckon, again, because I need a negative 1, so if I put a 2 there and a 5 there, I'm aiming to get a difference of only 1 between my multiplying along the cross. So 1x times 5 is 5x. 3x times 2 is 6x, and I needed a negative x, so I'm going to put the negative 2 there. It gives me the negative. So 5x, working down this way now, 5x to take away the 6x gives me negative x, so that works. So the denominator of the first fraction is now 3x plus 5 bracket x 2. And you'll already notice straight away, just in the first fraction, we have an x minus 2 on the numerator and x minus 2 on the denominator, so we can cross cancel, but we'll wait to the end to do all our cross cancelling. So now we're going to look at the second numerator. Okay, 6x squared plus 7x minus 5. First thing you should be thinking, we have a coefficient that is not 1, so I should be looking to take out the common factor. Can I do that? No, I can't. So then I go to my cross method. So let's do that. 6x squared plus 7x minus 5. Draw my cross. Variable cross. Factors of 6x squared. I'm going to try 3x. 2x. I have 5, so it's going to be a 5 and a 1. So go 5 up here and a 1 here. So if I multiply 2x times 5, that's going to give me a 10x. 3x times 1 is going to give me a 3x, and I need the 7, so I'll make that my negative. I needed a negative 5, so negative 1 times 5. Working down this way, 10x plus, sorry, that's going to be a negative 3x. 10x minus 3x is 7x. That's my middle term, so that works. So my second numerator becomes 3x plus 5 bracket 2x minus 1. That all over. Okay, and then finally, go back to blue, my last denominator. Okay, coefficient 1, so we're going to try the inspection method. It was 9x plus 14, so factors of 14, 7 and 2. 7 times 2 is 14, 7 plus 2 is 9, so that's going to become x plus 2, x plus 7, x plus 2, x plus 7. So now that we've got it done, let's do some cancelling. Okay, we had an x minus 2 and an x minus 2. We have an x plus 2 and x plus 2. We have a 3x plus 5 and a 3x plus 5. That means all we are left with from this giant looking monstrosity, all we are left with is 2x minus 1 on x plus 7. And we're done. Okay. So even though it was a really complex problem, it just had 4 simple things in it. Okay. It was a little tedious, it took a little bit of time, but it would just be like doing question 4, A, B, C, and D. It's just all combined into one expression in this case. Okay, and to finish, as always, a lovely extension question. So, as always, pause or you watch me go through the solution. Have a go. With all of these hard problems, you've got to get used to, especially now we're in year 10 maths B, but if you're thinking of going forwards to year 11 methods, part of the skill of a good resourceful mathematician student is you just grind it out. Grind out the answer. Okay, just because it looks hard doesn't mean you stop. So grind out the answer. So give it a pause right now, or otherwise I'm going to start. Okay, so straight away, I'm not going to talk too much through this being an extension, but both have coefficients, so they're going to be cross method. I'm going to... If you hear banging noises, that's my dog and cat wrestling outside the bedroom. 1, 5. Do the other denominator first too before I write anything out. Three. Okay, I need negative, so that will be negative. So 3x, negative 8x, down 5. Yes, that works. Okay, let's write this. We get 4, 4x minus 1, 2x minus 5, minus 4x minus 1, 3x minus 2. Okay, and you're going, great, Mr. St. Pierre, what the hell? We factorize the bottom, what the hell? The denominators don't match, so what can we do? Well, they're close. If you notice, we have a 4x minus 1 and a 4x minus 1 on both of these. It's only 2x minus 5 and 3x minus 2 that are different. So we can actually create like denominators. Okay, it's just we need to multiply. In this case, the first fraction, I'm going to multiply the top and bottom by 3x minus 2. Because 3x minus 2 divided by 3x minus 2 is 1, so they would cancel. So that gives me that. And over on this fraction, I'm going to multiply by 2x minus 5 and 2x minus 5. And all of a sudden, I now have a subtraction of fractions that have common denominators, like denominators, so I can actually perform the fraction. So I get 4, 3x minus 2, minus 2, 2x minus 5, all over 4x minus 2x minus 5, 3x 2. Okay, all right, great. What do I do now? Well, 3x minus 2 and the 2x minus 5, so I can't take those out as a common factor on the top. So in maths, in exams, tests and that, we're not going to give a big problem like this that's going to give you a big answer like this. If you get to this big answer like this, you need to think, what other things can I do that will give me opportunities to simplify? In this case, it's going to be expand the numerator and then refactorize, and then we might be able to cancel. So let's do that. We're going to get 12x minus 8 minus 4x 10 over 1. And that numerator can simplify to numerator can simplify to, what's that? 8x 2 all over 4x minus 1, 2x minus 5, 3x minus 2. That numerator can simplify again to 2x 1. And this is where I start to think, have I made, oh, that's 4x. This is where I start to think, have I made a mistake? 4, 12x, yeah, minus 8. Negative 4x plus 10, yes, 12 is 8x. 10 take 8 is 2. Hoping for a cancellation. I don't actually have my written solutions next to me, so you're going to have to bear with me in this video while I figure it out if I have made a mistake or not. Oh my god, okay. That's silly. Mistakes all the way back at the end. I had a 4x and a 1 and I put it as -1. It's 4x plus 1, 4x plus 1. Yeah, there we go. That's an addition all the way through. So again, I was going on my instinct that I know there wouldn't be a problem like this that would come out where it's not going to simplify. We're not going to do that to you. We're going to have something that's going to have a nice, elegant solution. So we get 4x plus 1, 2x minus 5, 3x minus 2. And we can cancel. We get 2 all over 2x minus 5, 3x minus 2. And at that stage, yes, that's as far as we can go. So I apologize for the little delay and the little mistake, and also if the cats and dogs were really noisy. But that's exercise 5D. Any questions, put them up on the Edmodo page.